This is section 6.4 on factoring using a quadratic pattern. And you'll notice it says quadratic pattern because in our example here we don't have a quadratic, we have x to the fourth, but it is in a quadratic pattern in that you have x to the fourth minus 2x squared minus 8. So I can still break this up into two sets of parentheses where x to the fourth breaks up into x squared and x squared. So normally when you have a quadratic, you have x squared in your original equation and you break it up into x and x when you separate it into your two parentheses. This time we have x to the fourth and we're going to break it up into x squared and x squared. And because you're using a quadratic pattern, you still want two numbers that multiply to 8 and add to negative 2. So my two numbers that multiply to negative 8 are negative 4 and 2, and then if you add them together you get this negative 2x squared in the middle. And then you can still factor from here. So because x squared minus 4 is a difference of squares, this breaks up or factors into x minus 2 times x plus 2. Now x squared plus 2, you can't factor that anymore, so it stays as x squared plus 2. So if you were to factor this completely, you'd get x minus 2, x plus 2, x squared plus 2. So example 2, you want to factor using a quadratic pattern. You have x to the fourth minus 5x squared plus 4. So again, x to the fourth is going to break up into x squared and x squared in each of my parentheses. And multiplies to 4 and adds to negative 5. I have negative 1 and negative 4. So my first step is to get it to say x squared minus 1, x squared minus 4. Now both of them this time are difference of squares. So x squared minus 1 factors to x plus 1 times x minus 1. And x squared minus 4 factors to x plus 2 times x minus 2. So when I factor that out completely, I want to use the I want to factor using quadratic patterns to get to this step, and then use difference of squares to get to this step. For my final answer, x plus 1 times x minus 1 times x plus 2 times x minus 2. And the last thing we can do with factoring using quadratic patterns is we can solve by factoring and find all the roots. So if I have x to the fourth minus 4x squared minus 45, and I want to factor using quadratic patterns, I'm going to have my x squared and my x squared. And then two numbers that multiply to negative 45 and add to negative 4 are negative 9 and 5. So now I have x squared minus 9, which is my difference of squares. So that's x minus 3 times x plus 3. And x squared plus 5 doesn't factor into anything. You keep it as x squared plus 5. When you're solving, don't forget you're setting each factor equal to 0 and solving it that way. So I have x minus 3 equals 0, x plus 3 equals 0, and x squared plus 5 equals 0. So this is x equals 3, this is x equals negative 3. When you get here, you have x squared plus 5. You don't have a b term, so you want to solve by extracting square roots. Remember the 3 ways or 4 ways of solving quadratics were factoring, extracting square roots, a quadratic formula, or graphing. But when you don't have a b term, the easiest way is by extracting square roots. So I'm going to subtract 5 from both sides, so I get x squared equals negative 5, where you can take the square root. So you have x equals plus or minus the square root of negative 5, and when you have that negative under the radical, you want to take out an I. So your final answer when you're solving this, you get x equals plus or minus I radical 5. And all 4 of those are your zeros for this equation.
Notice that you should have 4 zeros because it's a 4th degree polynomial. So 2 happen to be real and 2 are imaginary.